Today, we are excited to introduce Hayley Hassler, who is a research associate working with Jeff Townsend at Yale University. Hayley just finished her master's at Clemson. So, welcome, Hayley. Tell us a little bit about what you studied when you were at Clemson, and then also what you're doing with Jeff.
First of all, thank you so much for the introduction, Erin. So actually, the research I was doing at Clemson had a lot more to do with like bacterial phylogenetics and the evolution of those bacteria and kind of how that relates to microbiomes and things like that. But I've actually been studying something here that I'm sure we're all extremely familiar with by now, which has been the COVID-19 pandemic. And this research has actually been probably the most timely and important, not just to the general study of science, but quite literally to the world, research project that I've ever been a part of, because we're studying something that's just so relevant, which is the durability of immunity of SARS-CoV-2, aka the agent of the COVID-19 pandemic. And what's been just kind of so exciting about this research is that we're using genomic data and computational resources and evolutionary theory to answer a question that has been impossible to answer empirically at this point in the pandemic, which is the status or the durability of immunity for SARS-CoV-2 after someone has been infected. So how long can we expect to possess immunity against the virus before becoming vulnerable to reinfection?
Which is the most timely question right now with the Delta variant. Yes. In fact, yesterday I was having my hair cut, and that is what we were talking about, is the breakthrough infections and how long does immunity really last from the vaccine or from exposure. So are you studying that at all, the immunity after vaccine?
Right. So the natural infection research that we've been doing is getting published very soon. And we do have a follow-up paper in the works for the durability of immunity following the different vaccines. That's really exciting to be working towards that.
Yes. And you are definitely not the first student I've talked to, even within our lab at UVA, who has said, I never imagined I would be working on something so relevant.
Right.
Right. You kind of expect to, I don't know, look at the age-old problems. Let's look at cholera again, or, let's look at bubonic plague even, right? These things that have happened in the past that most of the first world doesn't think about. And now we are knee-deep in things that are so relevant.
Yeah, it's funny. I've never been asked so much about my science by my family before the COVID-19 as I have been asked now.
I'm sure all of a sudden you're the one that they turn to. You're the one that they're like, oh, we don't know the answer to this. I bet Hayley knows. We'll ask Hayley. Yeah. That's so great. So how did you get into this field at all, this interest in microbiology and working with the Townsend Lab?
So I actually got into computational biology in general, just because the class happened to fit into my schedule in undergrad at Clemson.
No way.
Yeah. Yeah. At the time, my PI, Dr. Tamara McNeely, back then, wanted some comparative genomics performed on some novel bacterial pathogens in this awesome collaboration with the CDC. And I was the only one in the lab whose schedule could actually accommodate the class.
Oh my gosh.
That taught those analyses that she wanted done.
Yeah.
So it was really, really just like luck for me. And interestingly enough, the professor who taught that kind of, I won't say life-changing, but definitely path-altering class for me, Dr. Vincent Richards, he later became my PI for my master's at Clemson. And it was him who introduced me to this wonderful world where computational biology meets evolutionary biology.
Yeah.
And that interest actually led me to reach out to Dr. Jeff Townsend at Yale, kind of as a huge fan of these crazy
Right?
phylogenetic theory papers I was reading.
Yeah.
And then I had the opportunity to meet with him where he offered me a summer research position last year that I've essentially never left. Because obviously there's this urgency throughout the pandemic to answer questions we can't yet answer empirically. And that allowed me to use my background in computational biology as well as evolutionary biology in a really novel way for me, such that we could actually provide like evolutionary justified answers to those pressing questions that can affect policy making decisions as important as, when we may need to get a booster shot.
Yes, that is something that I have heard over and over again, especially from the scientists that I've interviewed, the folks who are farther in their career.
Mhm.
Their advice has been say yes to all those opportunities because you just don't know what could come of it. I mean, you could have easily said, yeah, I don't think I want to take that class.
Yeah.
Do you know, like it's at 8 o'clock. I don't think I want an 8 o'clock class or whatever. But you didn't. You said yes. And the doors that opened from that.
Yeah, it definitely has just been kind of like this rolling ball that seems like it's picking
Right.
pace faster and faster.
Right. Yeah. This one connects you to that one and to that one. And it also goes to not being afraid to reach out to people. Like you said, when you reached out to Jeff, because you'd read some of his stuff,
I
he
was
could
shocked. I was
easily.
shocked that this, in my head, what seemed like a giant was willing to respond to me in such like a humble way.
Right. Right. And I will say, fortunately, that is a common theme, especially in this expeditions team. I I have spoken to giants, Simon Levin at Princeton, Rita Colwell, the first female director of the NSF, uh, humble, amazing people who recognize the opportunities that they were given and in turn want to make sure that other students have those opportunities. And Jeff is definitely in that category.
Yeah.
No question about it. So this is your whole research focus now,
Yes.
basically. And you've kind of alluded to who you think would be affected and impacted by your research. You want to talk about that a little bit more? Like, have you
Yeah.
seen that direct benefit?
Actually, compared to a lot of traditional evolutionary trait research, kind of like looking at the color of butterfly wings, that
Right?
question is fairly easy for me to answer in that the research has wholeheartedly been for the benefit of all of us who have felt the impact of the COVID-19 pandemic over the past year and a half. And that's been really, really exciting for me. Like I said, even just having my family take an interest because it's impacting them and it's impacting
Right.
all of us. So yeah, definitely for the benefit of anyone that has had any sort of question about this pandemic.
So where do you go next? How is this ball going to keep rolling? Where do you think it's going to roll to next?
Well, I guess right now I'm really hoping to, apply to PhD programs coming up. But I think as far as the research is concerned, just as you mentioned earlier, the vaccine research that we're looking at now, I mean, that's the next big question is approving these boosters. When do you need the booster? When is
Right.
it beneficial for the immunity? And I'm really hoping that that's the next kind of answer that we can provide.
And then what is your dream job? So 20 years from now when you're being interviewed for something, what will you be doing, do you think?
Actually, I think one of the most amazing aspects of this field is that it is growing and it's changing so rapidly that I think the types of jobs that actually exist in computational biology now may look very different 5 years from now, when I'm hopefully finishing my PhD. So while I don't quite have an answer for what I think my dream job might be, I do know that in general, research is always going to be a part of my career. And I'm certain that that research will be for the benefit of not just the scientific community as a whole, but really hopefully for my neighbor or your neighbor or
Right.
the person standing in the grocery line at the store, which has really been the most fulfilling part of the COVID-19 research that I've been doing with Jeff here at Yale, is just knowing that impact is there.
I completely agree. I'm on the administrative side of our COVID research. So I, push the buttons and send the emails and that sort of thing. But it really is rewarding to be part of the solution.
Yeah, absolutely.
I think. Okay, so do you have cousins or nieces and nephews?
Mm-hmm. Yeah,
Little people?
Mm-hmm.
So how do you explain to them what you're doing?
So this is a great and hard question. I'm pretty sure that the third graders that are out there now are a lot smarter than maybe I was as a third grader doing, shadow
Me too.
on like
Yes.
red projectors or whatever.
Right.
But I think maybe the best way I could describe it would be that, after you get sick, your body produces a whole army of fighters to help keep you from getting sick again. And over time, that army may naturally decrease, kind of like fighters retiring. But you, like I said before, you need a certain amount to help protect you from getting sick again. So what I'm studying is how long after you originally build up your army will there be too few to fend off that sickness again. So, AKA before you'll need to hire some new fighters. I think
like
that might be hopefully the best way I can describe it.
Yeah, I like that. That's really good. That's good. One of the students that I interviewed a couple months ago, he was studying sort of the modeling of the virus in general.
Mm-hmm.
And when I asked him that, I just love this answer, and I've probably said this to 50 people. He said, talking about social distancing, the way that he would explain it is that when the virus comes around, he's kind of a bully, and so you just want to stay in your house so that he doesn't have anyone to play with, and then he can go home. I thought,
that is great.
I know. I can just picture like a cartoon.
Yeah.
Of like, the bully virus coming into the playground and all the kids run home.
Yeah, and then they just sit there with nothing to do.
So he just goes away. I thought, that's so good. So I like your army visual. That's a good one. An army of fighters. Yeah, I like that. And then they get tired or they retire. They can't do that all the time. So now we need more.
A bit more. Yeah.
Yeah, just a little bit more. Is there anything else that you want to share with us?
Well, I guess maybe the results of the research.
Yes.
That's kind of been, it's a big question. The $1 million question that we now have kind of $1 million answer for, which is that the durability of immunity that we've kind of estimated in an evolutionary way is that it would be an average of 16 months or about 1.5 years, which coincidentally is about how long we have been in the pandemic and coincides with kind of these reports that we're seeing a lot of reinfection. So
right.
Unfortunately, our results are being justified, but also I think that having that knowledge is really going to be useful for us going forward and a way to mitigate this pandemic.
Yes, certainly. And more than that, it will be just interesting to see how the vaccine plays into that, how someone who has been infected and recovered and then been vaccinated.
Right, exactly.
What does that mean? Mm-hmm. And then the booster shots. How long are they going to last for?
So many different iterations of how this can occur.
Right. Yeah, it's fascinating. And which vaccine
mm-hmm.
is it? Because they're all a little bit different. Yeah. Oh my gosh, you have so much work ahead of you.
Which is really exciting too. That like you
yes.
said, the ball will keep rolling and we'll be able to provide more information, hopefully.
And now I know. I just need to call Hayley.
Yeah, you have to get in line behind my mom. But
oh, definitely. Mom always comes first. This I know for sure.
But thank you so much for having me.
Yes, thank you so much for joining us today.